This video I'll show installing shafts and motor mounts. This will typically be one of the first steps I do once the hull's cut out. Reasons for doing that are the shafts and motor mounts serve a base for where many other things are located, like the rudder post, for example. You also need to plan water channeling around it and or integrate water channeling into the areas where the shafts enter the hull. So in terms of materials, first part will be the shaft and stuffing tube. So here's a 3/16 inch shaft here from McMaster car. With this, it already has the props attached. This is from a different build that I used these shafts at first, but then switched to a smaller prop. Usually I would start with just sort of raw materials, just the shaft. So what goes around the shaft will be the stuffing tube, this tube here. So what I'll do is I'll get oilite bushings from McMaster that go over the shaft, and then they sort of slide into the stuffing tube at the end there. So from the layout step, I would have determined where the motor mounts are going to be and then cut the shaft to the right length. If you want to get a pre-assembled shaft, you need to know what length it's going to be, because they typically come in length increments with the stuffing tube. So for that, you'd want to just determine where the motor mounts are, determine where the props are, and then measure the length. But in this case, because I already have these shafts, what I'll do is I'll take this tube, which is 36 inches long, I'll cut it down so it's the right length for this shaft. And then I can sort of show how this all goes together. So in addition to the shafts, we have the motor mounts. These are Traxxas fill-in motor mounts, which are unfortunately no longer in production, but they were nice because they came with this aluminum motor plate, which gives plenty of strength for holding the motor in. The plate sort of bolts on the back there, and then you'll end up with motor, and then we'll have the stuffing tube come right in through the hole there. It results in a very clean setup, and then I'll have gears. So I'll have a larger gear on the bottom here and a smaller pinion gear on the motor shaft. Other materials, I have this piece right here, so I'll use this as a shaft strut. I've shifted to using metal because the shaft struts especially on a larger boat, have a lot of stress. This is a 4-shafted boat, so the shaft will be kind of unsupported outside the hull. So I'll use this to sort of wrap around the shaft and link it to the hull, and I'll show a finished version of that. Alright, along with the shafts, like I mentioned before, you'd also have the propellers. For this boat, I'm going to use 1 3/4 inches. It's pretty standard for a boat in the 50 to 60 inch range. Alright, so first steps, I'll cut this down to size, and I'll show a few other factors that go into that, and then I'll start mapping out where exactly on the stern I want the props to be. Show quickly what the finished product will look like in terms of shafts. So this is on Agincourt, but I'm going to be using the same idea on the South Dakota. So there's motor installed, you can see the gear. These are nice because there's no additional coupling needed between the shaft and the motor, whereas in direct drive, usually, well, you need a coupling between the shaft and the motor, and this could sometimes be a point of weakness. So you can see with Aggie cord here, the shafts end up going into the water channeling area. So that's a reason why I need to do the shafts before you do the water channeling, at least in the stern area. And then I'll sort of show this strut there. So there's metal strut to support the end of the shaft. And then you can sort of see how it lines up with the rudder. In general, you want the shafts to be have the props as close to touching as possible, and then the rudder right up against the shafts. When determining the shaft and stuffing tube length, the shaft will be a bit longer than the stuffing tube. That's because one end you'll have the propeller, and then the other end you'll have some sort of coupler. In this case, because I'm using the Trex gearbox and the driven gear will be directly on the shaft, I need to account for the gear, and then also put a collar on here. The collar helps retain the boat, or retain the shaft in the boat. The reason for that is basically all the force from the propellers, mainly when the boat's going in reverse, is going to fall upon the gear joint, or your coupler joint. So that's sort of where the force is going from the propeller to the boat. So in some cases, like this boat's going to be about 35 pounds. So in going from forward to reverse, you'll sort of rapidly be taking a lot of force from the propellers and taking the 35-pound moving boat and then rapidly moving it in the other direction. So that's why we'll use a collar in addition to just a drive gear, because you end up with basically like 2 set screws on the shaft holding the shaft in the boat. I've certainly seen, if the collar isn't tightened, that the shafts can come out the back of the boat or loosen enough that the gear starts slipping. So what I'll do is I'll want to know the width of the gear and then the width of the shaft. I'm also going to take into account the width of the flanges there on the oil light bushings, and then that'll sort of help determine how long the stuffing tubes need to be. And in this case, because I have the fixed shaft, I'm just going to use these. If I was making the shafts new, I would probably set the stuffing tube length first, and once that's set, determine the shaft length and account for those additional distances in order to cut it to the right size. Show the gears quickly. On a boat like this, I'll use 32 pitch gears, which are right here. Alternative would be 48 pitch, which maybe use on a smaller boat. But you can sort of just very clearly see the size of the teeth difference. So these smaller ones can strip a lot easier. The gears can strip. This specific gear I get from a company called Stock Drive Products. They are fairly expensive as a per gear thing, but these are stainless steel. They're very solid. For the gear that goes on the motor shaft, the motors I'm using are prop drive 35mm by 48mm, probably 900 kV. So the 5mm shaft, this is a 14 tooth gear. I think it's from Traxxas. But you can sort of see how they go together. I cut the stuffing tubes down to size and sort of did a mock-up assembly. So you can see the flange of the bushing there. And then on the other end, you can see the collar and then the gear would sort of go on there. These shafts already have a flat spot But if it didn't have a flat spot, then I'd grind a flat spot into it at some point. Maybe not at this stage, but at some point you need to do that. Alright, so these are ready. This next part will be determining where I want the props to go. To determine where to place the props, I'll flip the boat over, sort of look on the stern about where they can go. Considerations here: generally you want the props to be within the width of the hull at that location. So if you just think about it, like if the props were, I don't know, back here or so, there would they'd stick out, and then if you watch a battle video, the boats are running into each other a lot. So what I want to avoid is if a ship comes, you know, in its bow, like goes here, I don't want it to catch my propellers, because it's a good way to break the drivetrain. So generally I'll have, you know, an idea of what size props. So these are 1 3/4 props, although not the ones I'm using because I already have the ones brazed. They're representative. So what I'll do is, you know, you'll know, okay, here, what's my prop diameter, and then you'll sort of double that, and then that will be your sort of minimum width. And then if you can, I would try to have a little bit of a buffer, because, you know, the stern will typically be curved, so you certainly want it to be within the confines of the deck rim, but ideally it's more like in the confines of this hard area, and that'll sort of protect them better. Other factors will be, you know, what the stern looks like and how the hull slopes up. So for some hulls, like, the slope up will be more towards the stern, so it can be harder to get the props in. Generally you want the prop shafts to be as level as possible, which means getting the props as close to the hull here as possible. So, you know, I'll need to consider, most boats will have sort of this angled portion here, you know, they'll have the keel, and then they'll sort of angle up to where the propellers would go and the rudder. So obviously, like, I wouldn't want to put the props here because I have this middle, you know, this angled portion in the way. So generally, I'm probably going to end up somewhere around here, which will allow the two props to have their blades really close together. We'll see. You don't want them super close to the hull, because that can disrupt the flow of water and make them less effective. So probably generally this area. So what I'm working towards is I'm going to make a little guide like this. This is from another boat. I think this was Agincourt, or maybe Congo, I'm not sure. But what I'll do is I'll basically trace out prop diameter, and then I'll do this on an index card first, and then I'll just start with 2 circles showing, you know, what the props will look like touching each other, and then I'll basically cut out to match the contour of the hull. And then, you know, this one won't fit because it's for a different boat, but basically I'd attach, and I'll actually even glue this onto the hull, and that'll help hold the shafts in alignment when I fiberglass them into place. So I'll take my diameter from these props, and I'll draw it up on an index card and sort of show the process of figuring out the right shape to use. Started drawing out the prop guide. Typically what I'll do, I'll put a center line, which on the bottom of the hull can sometimes be hard to really determine, especially if the windows aren't cut exactly the same on either side, because the distance from the edge to the center can vary based on where exactly you cut it along trying to get the 45-degree. Another important factor when I talked about the width is it's good to consider the really width of the props themselves. So a lot of times it's easy to think, oh well, you know, as long as like I'll move the ruler forward until I hit the right width. But it's important to remember that the props themselves can be, I don't know, close to a ½ inch long. So where we want the guide to go can actually be about a ½ inch further forward. So I'll mark the first mark here, that's where I want the aft end of the props to go, and then the forward mark would be where I want to make my guide. Alright, for making the guide, I'll typically just draw something simple. So I chose a line, I spaced out my prop diameter, and then typically I'd have a protractor or something to you know, draw nice good circles, but since I moved I can't find it, so I just basically drew out half diameter, and then really, I'll just show sort of this as comparison here. What I want to assess is basically like what this curve looks like, and then I'll do that by just starting to sort of like, you know, cut a shape in this, and then looking at it, seeing where I need to vary until I get the shape to sort of match the contour. So when I cut the wood, it goes nice and smooth on the back here. Okay, to draw it, I'll sort of align the mark up so it's in the middle, and then I'll just sort of look and you know, try to match the contour to some extent. So what I did, I first put those marks out on the side, and then measured how far down the hull was from the straight line, which was 3/8 of an inch, and then I measured up 3/8 of an inch in the middle, and then sort of drew a curve in. I'm certainly not an artist. I'll cut this and then sort of see what it looks like. Okay, first cut's done, and it actually looks really good. This doesn't need to really be perfect. It generally matches the shape. Really what I'm looking for is just something that I can tack in a couple places to the hull and it'll hold in place. Leave it about, I don't know, 1/8 to a 1/16 between the hull and the arc of the props. That'll be good for the water around the prop tips and not creating too much of an issue. So I think that's pretty good. So the next step, I'll take this and I'll use some 1/8 inch plywood and trace it out onto the plywood, and then cut holes for the prop shafts. Cut my guide out. It doesn't really need to be perfect. Main thing is it you know, generally aligns with the contour of the hull, which it does. It's got the 2 holes. Okay, now that the shaft alignment's done, I'll install the shafts in it like this, and then sort of identify what angle the shafts will go at. So for this, I do need to flip the boat over and look on the inside of the hull. So what I'll do is, because I know where the shafts ends, I'll put a mark on the side of the hull so I know sort of where to look. And then I'll check with the motor mounts on the inside so I can determine where exactly the how the shaft could be angled. Okay, I flipped the hull over, and then I took my marks on the side there and the ruler and sort of marked where the end of the shaft is. And with my motor mount, the end of the shaft will pretty much align with the this part right here. So then take the ruler out, and then I'll just sort of, you know, line up where it can go. So at this point we could talk about toe in. Generally we'll try to toe the shafts in which means instead of the shafts being parallel, we'll have them sort of out like that. What that does is it helps push the thrust of the propellers towards the rudder, which can help turning a bit. So in general, we'll sort of push them out as wide as possible. This boat's sort of excessively wide, so I don't need to go all the way. It is good to have a little bit of space on the side there for can make it easier installing the motors. Then also if you have like tubes or wires that need to go back, then they can sort of easily go in this sort of slot. So I'll sort of put these in here, move them around a little bit, and then I'll sort of determine where these will be placed, and then that will determine the other end of the shaft. And then once you have both ends of the shaft decided, I'll align where to cut the shaft holes. At this point I'll also draw a center line. That'll help me make sure that the motor mounts are symmetric with the center line. So drew that there, and then it looks like going about 1 3/4 inches from center line for both. I flipped the boat back over, and I transferred the measurements from the inside of the hull to the outside of the hull, and then I basically marked where the shaft would go. I marked both the center, and then I marked 1/4 either side so you can easily see where it is. Then you basically put the guide where it goes, and then I tape them down because it's kind of hard to hold. And then the next step is to determine where the holes you need in the hull are. So for that, what I'll do is I will trace, by just taking a Sharpie along the side, and then mark grooves like you see there. And then, because of this sort of steep curve here, I expect the penetration will be, sort of in this area. So, then I'll have the lines here, so then I'll sort of pull the shafts off, and then just mark out 2 slots to put the shafts through. Sometimes the holes are the right size on the first try. If you need to make it bigger, not a big deal, just cut away a little more until there's plenty of clearance. It'll all be filled in with fiberglass, which is the same thing the hull's made out of, so having too big of a hole isn't really a big deal. So I'll mark those, cut the first holes, and see how I did. I have the first holes cut. See the shafts are up a bit too high of an angle, so I think I'm pretty good on the aft hole, and then I'll just extend these ones a little bit, grind it down so it's a bit of a smoother transition, and then the hole should be good. Finished cutting the shaft holes because the hull on the South Dakota was so thick. I had to grind a pretty good groove in it here with the starboard shaft, and then a little bit for the port shaft. So now that this is done, I'm ready to start thinking about epoxying these. Some other steps I didn't show was I had to drill out the gearbox a little bit to get the shaft to go through. That's done. Also, I will typically rough up the bottom of these. So do that really with any plastic surface, which will help the epoxy adhere to it. Alright, in terms of epoxy steps, this will actually be done in probably 3 epoxy jobs. So the first one will be the motor mounts, these guys. For that, on this hull it's going to be really easy because these are nice and level. So I'll probably put like a layer of fiberglass mat underneath, which will help fill in, prevent any gaps between the hull and the mount, and then really just put it down on top. I'll set up a little epoxy barrier, perhaps. On other hulls that have narrower stern, sometimes I'll have to grind the mounts down a bit to keep a good angle, but these ones you can just put in flat. So first epoxy job, we'll do the mounts. The reason to do them separate is because I'll want to be able to pick these up and place them down on top of the epoxy. And then the next one will be the shafts. And I can't do the shafts at the same time as the mounts because I need to move the shafts when I put in the mounts. And then to do the shafts, you have to seal up the outside and then fiberglass it from the inside. And then last thing would be I'll do the shaft struts at some point. So for those, I'll have to cut those out of metal, bend them into the right shape, drill holes for them so they're the right place. When I'm getting ready to do the epoxy job, I'll take my little guide here and I'll actually glue it into place. That'll help keep it in the right place because it sort of just sitting here, it moves around quite easily. So it's hard to get it exactly right. Next I'll be gluing the prop end holder into place. So I have my mark from before. So I'll use CA glue and kicker, and I'll just put a few spots along the contact point there, and then that'll help hold it in place, which will make aligning them in the hull much easier. You can also sort of get a sense for what the props look like, nice and close together, and then pretty close to the hull. On this boat, I'm considering not using shaft struts because these are the sort of exposed end here is going to be so small. So we'll see. When I go in fiberglass from the inside, I might just have it, come up to about here, in which case, strut is really unnecessary, because otherwise, like, if I had it here, then you'd have the strut just like an inch away. It might not be needed, save a little bit of work. So I'll glue this in place, and then I'll get ready to epoxy the motor mounts in. It's glued in place. Now it's nice and solid. You can do a sanity check, make sure looks like the shafts are generally aligned, and it's not ridiculously off center. Check from both directions. Looks good. So now that end will be fixed. I'll be careful when I flip the hull over because these do stick down below the bottom of the hull, so I'll put something underneath it. I have it flipped over, everything pretty much ready to go. I'll just highlight the gaps I was talking about. So there is a little bit of gap right at the base there, which is kind of expected because the shafts do have a slight down angle moving aft, so the bottom is flat, so the shafts are at an angle, so you would expect a little bit of separation. To fill that up, I'll use fiberglass mat, which does a good job of filling in those gaps and then not really running anywhere. So I'll cut a few pieces, slightly larger than this base, so I have them ready to go. And then I will be ready to epoxy. Typically I would put sort of barriers around, but especially if I had to build up fill in a much wider gap that I need to use some sort of paste to do. But since I don't need to do that, I'm not going to worry about it for this build. One thing to check on a mount like this is making sure that the shaft isn't, or the stuffing tube isn't sticking too far. So for example, if the stuffing tube was like this, I wouldn't be able to fit my collar or the gear in there. So I built several boats with this hardware. So I'll usually put the so just a tiny bit of the tube is sticking out. So the flange is going up against the tube, and then make sure it's set there when I glue it in. I'm also typically, because these are sort of loose, I will when I go to slide this in, I'll put some epoxy on this joint, or maybe even something like E6000, just a little more flexible. I'll put it on this joint, so when I slide it in, there's adhesive between the stuffing tube and the motor mount. Alright, I'm ready to go with the epoxy. So like any epoxy job, first step, I'll clean both surfaces with acetone, make sure there's no extra dust. Then I'll cut out pieces of mat. So this is 1.5 ounce mat. Same material I use for the hull. It's good because it's got some thickness to it, so it'll fill in those gaps nicely. So, and then I have some little pieces to fit in, mainly in the center and then on this back edge. The first epoxy job is done. One thing I almost forgot was attaching the plates to the mounts before installing. I made that mistake once. It's much easier to install it before installing in the boat. So these, nice level. One thing I'll do is typically epoxy will cover up the marks I have for alignment, so I drew some lines on the hull just to line the shaft up. And I'll let this dry, and then next step will be epoxying in the main shaft joints. The motor mounts are epoxied in, so next step will be to prepare to fiberglass around the shafts. To do this, I'll use electrical tape and just put a bunch of pieces to seal this up. Keys for this step, to make sure I don't bend the shaft when I'm taping it. So if you tape it really hard, you can bend the stuffing tube a little bit and the shaft won't be clean. And the other main thing is just make sure you have a good seal, because the tape will be a liquid barrier when you flip it over and fill it with epoxy. Finished taping up the shaft holes. Generally the hardest area is at the end here. So to do that, I'll sort of put a piece across, and then at the top and bottom cut the corners, fold it over. Okay, I'm ready to start epoxying. So I've prepared some fiberglass cloth. I put up a little bit of barriers. This boat really isn't going to need much. And then I've mixed epoxy, so I have some that I added milled fibers to. This helps give it more strength, and then some that's just epoxy that I'll use for the fiberglass. So when I'm starting, I'm going to fill in these voids. Main thing I'm thinking about here is just avoiding air pockets. So I'll just sort of let it flow, and then I made a couple of vent holes. sort of put it all the way around the shaft there. Okay, you can see it's just about full. So it's pretty much full. It will want to kind of flow out a little bit, so I'll probably start using some fiberglass cloth and mat to prevent it from flowing out. Finished adding epoxy and fiberglass. Ended up having a lot of extra, so I poured it in the middle. Typically I wouldn't do that, but that area will need to be filled in for water channeling anyway. I like to use the fiberglass cloth to curve over the shaft. You can sort of see it. I did have a minor leak on the port shaft there. I stuck some plumber's putty around the tape to hopefully stop it so it doesn't all drain out of the cavity. If it does, not a huge deal. Usually can fill it in from the outside if needed. So I'll let this set up and see how it turns out in the morning. Remove the tape from the shafts and then put the props in. So you can see using the electrical tape gives a nice smooth finish. Blends right in with the hull. So for this boat, the shaft install is just about done. I'll do finishing touches to sort of grind the rough up the epoxy. I quickly installed the motor and gears just for demonstration purposes to show how it looks like. So see here, it's a pretty clean setup with the shaft going straight into the gearbox, and then the gears. This is an outrunner brushless motor, so the can spins. There's a little cover that goes over, which covers up the gears when the boat is running to prevent items getting stuck in there. I wanted to show the shafts on the Scharnhorst because I'm using these flex collet couplers to mount between the shaft and the motor. These things are pretty cool. They're able to convert from the 5mm diameter of the motor shaft to 3/16, which is the prop shaft there. You can get them on eBay. I think they're about, I don't know, like $7 each. But they're pretty nice. So you can see here, I'm about to glass these shafts in. So I got the motor mounts there, and then I got the props with the shaft strut on. In this boat I'm powering the outboard shafts to hopefully make it go straight in reverse. In general it's not common to power the outboard shafts. Usually you just power the center shaft on a 3-shaft boat or the 2 inboard shafts on a 4-shaft boat. But the idea here is, you can see I glassed the motor mounts in first. So they're just little aluminum 90-degree angles. So I cut a slit in the hull, put them through, and then glassed the underside. And kind of cut out holes to fit the motor and then for the bolt holes. And I made sure they were lined up with the shaft angle that I wanted. But you can see that the flex collet couplers, they're pretty rigid in that you have to have pretty good alignment between the shaft and the motor. There's a little bit of wiggle room, so you can move this around a bit. What I like to do is actually, I have it hooked up there, and I can spin it and I can feel the resistance. So if it's kind of at a weird angle, the resistance is going to go up. So you make sure it's well aligned. But by, having the shaft hooked up to the motor, when I fiberglass this in, I know the alignment is going to be just right. What I'll do before that is on the shaft struts there, which is just a piece of brass, like bar stock that I bend around, is I'll put some glue on this joint, some E6000 probably, and then I'll use some CA glue up here to kind of hold it in place so the shaft can't move. And then I'll cover the underside of those holes with some electrical tape, and that will seal it up, and then fiberglass it from the inside. I hope this video was helpful. Thanks for watching.